thermal conductivity of metal rod experiment in our heat transfer laboratory. The aim of this experiment is to find out the thermal conductivity of the given material. So, in this experiment we considered copper as the metal and going to calculate the thermal conductivity of the copper metal rod. For that one, this is the block diagram of the experiment. Observe this diagram. This is the length of this is the rod, and the length of the rod is 400 mm. Four thermocouples are mounted on that rod at each equidistant, and two ends are provided to that rod. One is the hotter region and second one is the colder region. In this hotter region, one heater is provided to give the heat input to the rod, and another side water jacket is provided to absorb the heat from the rod. After that, two thermocouples are mounted on the water jacket. One is to calculate the water inlet temperature and another one is to calculate the water outlet temperature. Thermal conductivity value is obtained, find out by using the Fourier law of heat conduction. According to the Fourier law of heat conduction, Q equal to minus Ka into dt by dx. So, in this formula, K means thermal conductivity. We need to calculate the thermal conductivity value. So, K equal to minus Q by A into dt by dx. So, in this Q means heat input to the rod and A means cross sectional area of the rod. Here we are considering the cross sectional area only because heat is transferring along the longitudinal direction, not in radial direction, because here we provided the insulation to the rod to resist the flow of heat in the radial direction. That's why we considered the cross sectional area only. After that, dt by dx means temperature gradient. Temperature gradient is calculated by using the graph. Let us go with the experimental setup. This is the experimental setup of thermal conductivity of the metal rod experiment. This is the copper metal rod. The length of the copper metal rod is 400 mm and diameter of the copper metal rod is 20 mm. Here, four thermocouples are mounted on the surface of copper metal rod at each equidistant, and this one is the insulating material provided around the copper metal rod to resist the flow of heat in the radial direction. Here two ends are provided to the copper metal rod. One is the hotter region and second one is the colder region. In the hotter region side, one heater is provided to give the heat input to the rod, and second one cooling water jacket is provided to absorb the heat from the rod. Here two thermocouples are provided to know the water input temperature and output temperature, and after that this is the control panel of the setup. In this is the console switch, and this is the main switch of that panel, and this one is the power indicator and channel selector. By using this to know the temperature values at various positions, and after that this one is the power indicator and dimmer stat. By using this power indicator and dimmer stat to control the power input to the heater, and by using this power indicator to know the how much amount of power is given to the heater, and this one is the heater switch, and this is the glass beaker and stopwatch. By using these to calculate the mass flow rate of the water. Let us go for the experimental procedure. Before starting the experimental procedure, I am giving the mass flow rate of the water to the equipment, and at the same time set up the fixed mass flow rate value. By using this glass beaker and the stopwatch, I am calculating the mass flow rate here. I am calculating this mass flow rate. By using these two, after calculation, By using these two, I am fixing the 0.5 liters per minute of the mass flow rate throughout the process. I am not varying the mass flow rate value here. I am maintaining the same 0.5 liters per minute of the mass flow rate throughout the process. And I am switch on the power supply to the equipment, and this is the console switch, and this one is the heater switch. First of all, I am switch on the console switch. By using this console switch, the power is distributed throughout the panel, and after that I am switch on the heater. By using this thermostat, I am giving the power supply to the equipment. Some amount of the power is given to the equipment. This power is transmitted through rod by using the heater, and this one is the temperature indicator and channel selector. By using this channel selector, observe the temperature values at various places, and after that observe the water inlet temperature and water outlet temperature. Both values are observed by using this temperature indicator and the channel selector. First of all, observe here the temperature values are varying with time because it is in unsteady state position or transient heat conduction position. Wait, the temperature reaches up to the steady state condition. After reaching the steady state condition, tabulate the values and go for the calculation. Initially we calculated the mass flow rate value like this, 0.5 liters per minute, and this mass flow rate value is maintained throughout the process and from starting to the ending, and this liters per minute is converted into the kg per second, 8.33 into 10 power minus 3 kg per second. Initially we giving the heat input value 50 watts of heat is given to the rod, and this 50 watts is maintained throughout the process, and initially the values are like this, and after the 10 minutes the values are varied like this, and these are the values varied after the 10 minutes, and again after the 10 minutes we taken the values, these values are like this, and after that we waited up to the 30 minutes. After the 30 minutes the values are like this, 100.1, 80.1, 62.6 and 48.1, 29.0 and 29.6, and again we waited the 10 minutes. The variation is no change between the before the 10 minutes and after the 10 minutes. The variation is very less, so we considered that these values are steady state values. By using these values, go for the calculation part. Here you have to calculate the thermal conductivity value. So K equal to Q by A into delta T by delta X. We know about that, and the discussion about this already completed the discussion about this, and come to the Q. In this we need to calculate the rate of heat flow Q value. Q value is calculated by using the formula mCp delta T of water, because the rate of heat flow within the rod is equal to the heat gained by the water. That's why I applied this formula, and mass of the water is calculated 8.33 into 10 to the power of minus 3, and all of you know about the specific heat of the water. The specific heat of the water is 4180 joule per kg degree centigrade, and delta T means water inlet and outlet temperatures 29.6 minus 29.5 minus 28.9, 20.89 watts. Calculate the area. All of you know about the diameter of the rod. The diameter of the rod is 0.2 meters, and area is calculated, cross sectional area I am going to calculate 0.02 pi by 4 d square. (3.14 into 10 to the power of minus 4 meter square). and come to the temperature gradient, that is delta T by delta x, and delta T by delta x value is calculated by using the graph. Let us see the graph. This is the graph plotted by using the steady state values, and length of the rod is considered into the x axis and the temperature is taken into the y axis, and the scale of the x axis 1 centimeter is equal to 40 mm and y axis 1 centimeter is equal to the 10 degree centigrade. So by using the values I plotted the graph here, and after that I taking the slope of the graph. We know the formula for slope equal to the y by x. Y means temperature on x axis and x means difference of dt by dx value on x axis. By using these values I calculated the slope value dt by dx is equal to the 0.199 into 10 power 3. According to the graph, the temperature gradient value is calculated dt by dx equal to 0.1993 into 10 to the power of 3 degree centigrade per meters. So substitute all these values, heat input value q and area dt by dx, substitute all these values in this equation, we will get the thermal conductivity value. Calculate this one by using the calculator. $333.81. Watt per meter degree centigrade. So finally we obtained the value of thermal conductivity of copper metal rod is equal to 333.81 watt per meter degree centigrade. This is the final result of our experiment. Thank you.